Today's lesson is on transversals. Now, transversals are lines that intersect two or more lines. That's all a transversal is. And in general, it's not really the most spectacular thing to look at. However, when we have parallel lines being cut by a transversal, we get a lot of properties and some really interesting behavior happening. So what I want to point out right now is that we have a set of parallel lines that are being cut by this one other line. So I've went and I've labeled these as parallel. We use triangles as symbols to show that lines are parallel. And then I labeled this line that's intersecting them as T for transversal. So we know what our transversal is, and we can see that we have lines that are being cut by it. I've also labeled all of these angles on the inside because we're going to be referring to them in a minute or so. When we cut parallel lines by transversals, we start coming up with some really interesting properties. Alternate exterior and interior, consecutive exterior and interior, and something called corresponding angles. So let's real quick just go over what the differences between some of these words are. Let's look at exterior. Exterior is all the stuff outside of our parallel lines. Remember, lines go on infinitely, so we're talking about all this stuff up here and all this stuff way down here. That's the exterior. Interior is all the stuff on the inside of these parallel lines. So it's all this stuff in the middle. But then we see some of these lines, like words like alternate and consecutive. Alternate has to do with the transversal itself. Alternate means that they're on opposite sides of that transversal. So if we're talking about an angle on this side compared to an angle on the other side, they would be alternates. Consecutive has to do with being on the same side of the transversal. So we would want to be looking at angles that match up on this side, or angles that are lining up all on this side. So when we put that together, when we look at alternate exterior, we're looking at angles that are on the outside of those parallel lines on opposite sides of the transversal. So here we see that angle 8 and angle 4 are alternate exteriors. We also see that angle 1 and angle 5 are alternate exteriors. In fact, I'm going to write down those examples. We said angle 1 and angle 5, and we said angle 8 and angle 4. Now these are pairs of angles. What's really important about them, though, where the parallel lines come into play, and what makes them special, is that alternate exterior angles, that relationship, they are congruent. Okay, angle 1 and angle 5 are congruent to each other. So we're going to put down that they are congruent. That's a huge property. Also, we mentioned that angle 8 and angle 4 were alternate exteriors, so we're going to mention that they are congruent. Now let's take a look at the alternate interiors. Angle 7 and angle 3, they're on opposite sides of the transversal, and they happen to be inside of our parallel lines. And again, alternates happen to be congruent. So we know that angle 7 and angle 3 are congruent to each other. Angle 3 is congruent to angle 7. We should also notice that we have another set, angle 2 and angle 6, which makes those congruent as well. Consecutives. We're looking at consecutive exterior. So again, we're looking at the stuff on the outside, and we want them to be on the same side of the transversal. So if I look at angle 1 and angle 4, they're exterior angles that are on the same side of the transversal. The second set that we would have would be angle 8 and angle 5. Now, consecutive angles are not congruent. However, they do hold a special property in that they are supplements. So I'm going to make a little note. up here I recognize these two as being congruent, but these ones I want to mark as supplements, and I'm going to abbreviate here. So angle 1 and angle 4 should add to 180. Angle 5 and angle 8 should add to 180. Consecutive interiors. Angle 2 and angle 3, interior of the parallel lines, same side of the transversal. So that makes angle 2 and angle 3 supplements. And the other set we have is angle 6 and angle 7. Okay, those angle pairs will all add to 180. And the last one we have is this thing called corresponding. This one becomes tricky. A lot of people kind of forget the difference between corresponding versus some of these other properties. Okay, corresponding, we're going to have one interior angle, one exterior, both on the same side of the transversal, and they're not going to be adjacent to each other. So if I look at angle 1 and angle 3, these two are consecutive, right? They're on the same side of the transversal, and I have one interior and one exterior, and they're non-adjacent. So 1 and 3 are our corresponding angles. The really important thing to know about corresponding is that they are also congruent. So I'm going to make a note of that, and I'm going to list the corresponding angle pairs. We mentioned angle 1 being congruent to angle 3. Another pair would be angle 2 congruent to angle 4. And then we have the other sides too. We have angle 5 and angle 7 that are corresponding, which makes angle 5 congruent to angle 7. And last pair would be angle 6 congruent to angle 8. Okay, so that's how all those properties work, and that's what these particular words mean. So if you can remember alternate being opposite sides of transversal, exterior would be on the outside of the parallel lines, interior is on the inside, consecutive is on the same side of the transversal, corresponding is really the trickiest one of them all. So really practice these things the most, because if you understand what these vocab words are telling you, the rest of this stuff just kind of falls into place. That was a long bit of information, so we're going to look at a couple of examples of how to use these things. Let's say that they give us a problem, and they say that we want to find all these missing angle measures if the measure of angle 1, let's come up with a number like 45 degrees. We want to know the measure of all these other angles if angle 1 is 45 degrees. So before I even look at these problems, I'm going to look over here and I'm going to start marking down all the stuff that I need to know. I know angle 1 is 45 degrees. It told that to me, so I don't have to think about it. And now I'm going to start using some of these properties up top to fill in the rest of these missing angles. And I want to use the congruency part of this because I know what 45 for one of them is. I know that the rest of the ones that are congruent to 1 will have to also be 45. So I'm going to take a look. If I look at alternate exteriors, which are congruent, I know 1 and 8 will have to be congruent, so that makes angle 8 45 degrees. I also know vertical angles are congruent. That means that angle 1 and angle 4 are also 45 degrees, and if I look across from angle 8, angle 5 is vertical, which makes it congruent. I also should recognize real quick that alternate interiors are congruent, so that worked out, and corresponding angles are congruent, so those work out too. Now, how do I get angle 2? Well, if I take a look real quick, I can recognize that angle 1 and angle 2 create a straight line, so they're supplements. So real quick, I would want to do something like this. 180, which is a straight line, minus angle 1, which is 45 degrees. That's going to leave me with 135. So let's mark angle 2 at 135 degrees. Angle 3 would have to match it, because it's vertical. Angle 3 and 7 are corresponding, so that makes angle 7 135, and that's going to give angle 6 as well as 135 because it's vertical to 7. And again, we can check some of these other properties too, right? Alternate interiors are congruent, alternate exteriors congruent, correspondings are congruent. All these things are working really well for us right now. So when I go back to look at the problems that they're asking me for, now that everything's labeled, all I have to do is just write down the answer. I've done all the work for it already. So angle 2 we know is 135 degrees. Angle 3 is also 135 degrees. Angle 5 is 45 degrees. 7 is 135 degrees. And 8 is 45 degrees. So the work we did was right here. It becomes really quick once you're familiar with how these properties work, and then we just fill in the blanks afterwards. Let's look at a couple more problems. Here they give us an example, and they tell us to solve for x. And then they start giving us all this information. Well, we're going to mark down some of these bits of information. I might not want to write all this stuff in here because there's not quite a lot of space, but I am going to mark the angles that they tell me because that's going to help me visualize what the relationship between them are. So, it says angle 2 has some angle measure, whatever it is, and angle 8 has some angle measure. What's more important is that I see that they have a relationship of being alternate exterior angles. And if I go back to what my definition said, alternate exterior angles are congruent. So that's useful because they gave me a measure and they gave me another measure, and if they're congruent, that means we can set them equal to each other and solve. So 3x minus 4 equals 2x plus 7. I'm going to subtract 2x from both sides. I'm going to add 4 to both sides. That eliminates these pieces, and that leaves me with x equaling 11. Super easy once we realize that they're congruent angles. Let's take a look at the next problem. This next problem says angle 4, which is this angle right here, and angle 5. All right. Well, I should recognize those as consecutive interiors. So when I go back to my little pieces of information, it says that consecutive interiors are supplements, which means that they add to 180. So I'm going to take this information, 15x plus 12. I'm going to add it to this other piece of information, 5x plus 8. And if I do everything right, I should realize that they all add to 180 because they're supplements. Combining like terms, I have 20x plus 20 equals 180. If I subtract 20 from both sides, that's going to leave me with 20x equaling 160. Divide by 20 on both sides. That gives me x equals 8. Okay, the algebra part you guys should be able to handle with no problem. It's recognizing how to set these algebraic expressions up. Let's take a look at their last problem. Measure of angle 3, that's this one right here, and the measure of angle 7. Again, before I do any work, I'm going to recognize the relationship. I have corresponding angles, right? One interior, one exterior, both on the same side of the transversal, non-adjacent to each other. Those are corresponding, and I know that corresponding angles are congruent. So, again, just take the information, set them equal to each other. So I have 7x plus 25 is equal to 3x plus 1. I'm going to subtract away 3x from both sides. I'm going to subtract 25 from both sides. So that clears some stuff away. That leaves me with 4x equals negative 24. Dividing by 4 on both sides gives me x equals negative 6. Okay, so really, the algebra shouldn't be a problem for you. What you really want to practice is recognizing the relationships between the angles when they tell you what you have, regardless if it's just figuring out the angle measures like we did in this example, or if we're trying to solve for x. We have to know the relationship between the angles in order for us to start setting up problems based off of this information up here. Alternate exteriors being congruent, consecutives being supplements, and corresponding being congruent. So this is really the really important stuff. The rest of this stuff is it's just algebra. I really hope that that one helped you. If you guys are having difficulties with it, try checking out some other videos on YouTube, because I'm sure that you're going to find tons of practice problems. You can also go on CUDA software on Google and look up transversal practice problems. They have answers built in with them. I really want you guys to practice this type of stuff, because although it's really easy, it's memorizing this stuff that can become the challenge.